Section 9.6 is modeling with trig functions. And before we get started, all of the problems in this section are structured kind of with fill-ins. Before each problem, I would pause the video and write down the fill-ins and their blanks and stuff like that. It'll just help keep your work more organized and make it easier to look back on it. So example 1 says you're riding a Ferris wheel. The graph below represents your height in feet above the ground at any time t. So A says, what are your x-intercepts? So if you think about a Ferris wheel, it's a circle, right? So you're going around in a circle. The longer you're on the Ferris wheel, the longer you're going to go along the x-axis, or in this case, like the t-axis, because that's representing time. And then your height in regards to the ground is represented by the y, or in this case, the h-axis for height. So like at 0, you're starting at 0, and then you're going up. You're going in a circle, so you come back down, you're back at the bottom again, you go back up, you come back down, and so on. You keep rotating around the Ferris wheel. So A says, what are the x-intercepts on the graph? So we have an x-intercept at 0, at 40, and then this would have to be at 80 over here. So 0, 40, 80. And then B, what do the x-intercepts represent in relation to your ride? So we just talked about how like the graph is showing us rotating around this circle. So the x-intercept is when we're at a height of 0, so that's when we're at the bottom of the ride. Think like when you first get on the Ferris wheel. So x-intercepts represent the bottom of the ride. C says approximate how tall is the Ferris wheel. So basically, like, what is the distance from the bottom of the ride to the top of the ride? So we can see that here. So the bottom ride is at 0, the top of the ride, this is all the way up at 80 up here. So the ride in total would be 80 feet tall. And then D says if one ride includes 4 complete revolutions, how long is your ride? So we want to figure out how long one revolution is to start. So if we're starting at 0, we go up, we come back down, and then we're back at the ground again. That's one revolution, and that took 40 seconds. So we want to take that 40 seconds for one revolution, and we want to multiply it by 4 revolutions to get our total time to go 4 times around the circle. So 40 seconds times 4 revolutions is 160 seconds. And you can put it in terms of minutes. If you want, it would technically be 2 minutes and 40 seconds. And then E says describe the function in terms of translations of the graph. H equals cosine of t. So it's telling us we're going to use cosine. Technically, we could use sine or cosine, but we're going to use cosine. So I'm going to skip amplitude, and I'm going to go to the midline first. So remember, the midline is a horizontal line that cuts the graph in half. So if we draw the midline on our graph goes from 0 to 80. So our midline would have to be at y equals 40, so that blue line now. And then for the amplitude, actually we'll go ahead and fill in the midline now. So we just said is that y equals 40, it's just halfway between 0 and 80. And remember, the midline is a line, so it should be written as like an equation, not just 40, but y equals 40. And then the amplitude is the distance from the midline to the maximum, like the top of the Ferris wheel, or the midline down to the minimum. So just basically like half of the total distance between the two. So from our midline up to our max, we're going from 40 up to 80. So our amplitude would have to be 40. And then the period is how long it takes to make one complete revolution. We just kind of talked about that when we answered for part D. But if we're going from 0, we go up around the circle and back down, and that's one complete revolution, and that took us 40 seconds. So the period is 40 seconds. That's just like a fancy word for how long does it take to make one complete revolution. And then for the phase shift, so since it's telling us that we're using h equals cosine of t, that was the equation that was given to us, we know that cosine starts at a maximum or a minimum, like if there's a reflection, but since there's no spot to really talk about if there's a reflection in this problem, we'll just do a cosine graph with a phase shift. So cosine starts at a maximum, which our first maximum is right here. Normally we would start at like 0, and then instead of starting at 0 though, we're starting all the way over here at looks like 20. So we're going to say there's a phase shift of, in this case, 20 seconds to the right. So our phase shift would be positive 20. So one more time, the phase shift is coming from, typically with cosine, we would start like at 0 and then at a maximum, but we're not starting at 0 at our maximum. Our first maximum is happening, like, let me erase some of this, a little cluttered. Our first maximum is happening right here, which instead of at 0, it's happening at 20 seconds, and then our high point 80. So phase shift of 20. Okay, before the next problem, we have a new definition. It's frequency. Frequency is the number of cycles per unit of time. It's just the reciprocal of period. So you know our formula for period is 2 pi over b. The reciprocal, or for frequency, it's b over 2 pi. So basically, whatever the period is, you can flip it upside down to get the frequency and vice versa. So example 2, an audiometer produces a pure tone with a frequency f of 1,000 Hz as cycles per second. The maximum pressure P produced by the pure tone or from the pure tone is 20 millipascals. Write and graph a sine model that gives the pressure P as a function of time t in seconds. Okay, so I'm going to skip amplitude for a second and I'm going to go down to period. So it doesn't tell us anything about the period, but it does tell us the frequency, which we know frequency and period are related. So it says that the frequency is 1,000 Hertz. And up here it says that frequency is the reciprocal of period. So if I want to take, or if I want to find the period, I can just take the reciprocal of 1,000. So the reciprocal of 1,000 is 1 over 1,000. Another way of doing it is you could technically take the 1,000, set it equal to the formula for frequency, solve for b that way, and then find your period. But I think it's easier if you just take the frequency and flip it upside down, or take the reciprocal of it to get the period. And then just leave yourself a little note that finding the period is just the reciprocal of frequency. Okay, and then amplitude. So it doesn't say amplitude anywhere in the problem, but there's one other piece of information in the problem that we haven't used yet, so we should kind of look there. It says that the maximum pressure P produced from a tone, or from the pure tone, is 20 millipascals. And then the problem itself tells us to write and graph a sine model that gives the pressure P as a function of time. So our kind of like output of the graph, like we know if it's sine, it's going to be going up, down, up, down. It's showing how high the pressure is going up and down as time moves forward. That's what that kind of swirly shape is going to create. So if our pressure is 20 millipascals, that's our amplitude. That's how far it's going up, and then how far it's going down from the midline as time goes forward. So our amplitude is 20. And then for writing our function, we have that kind of like formula where it shows us where to put each different variable in the sine or cosine equation. So it's a, and then sine, in this case, b of x minus h, and then plus k, but we won't need h or k because there's no phase shift and there's no like vertical translation, no midline change. So amplitude is a, and then we need to figure out what b is before we can plug it into our equation itself. So right now we know the period, but we don't know b. On the graphing problems, or on like previous problems, we've known b, but we have to find the period. It's kind of like backwards for this. So before we can figure out what b is, we're just going to take the period and set it equal to its period formula. I'm going to do that off to the side down here. So we'll do 1 over 1,000. And then set that equal to the formula for period, which is 2 pi over b. And then now the only unknown in this problem is b, so we're able to solve for it. Alternatively, you could also take the like frequency up here, 1,000, and set that equal to the formula for frequency to solve for b. It works the same exact way. We're just plugging like reciprocal or the original. It doesn't matter. We'll both end up with the same exact b. Okay, so we have a proportion, so we're going to cross multiply. So we'll do 1 times b. So b equals 1,000 times 2 pi, so 2,000 pi. And then we have b, so there's nothing else to do. That's the b that we plug into our equation up here. So we know a, we know b. A is 20, so it'll be 20. And then sine, and then b is next, so sine of 2,000 pi. And then there's no there's no phase shift, there's no midline vertical translation other than the midline just 0. So we just need our x now, but in this case it's supposed to be a function of time, so I'm going to put t instead of x. This should have been a t down here as well, just because our input was time. Okay, so when we set up our graph, remember we have to take our period, and that's going to be like the furthest point that we go to on our graph. So for our graph, we'll go from 0 to 1 over 1,000, but before you write that, I have to take that 0 to 1 over 1,000, and I have to break it down into fourths. So I think it's a little bit easier if instead of 1 over 1,000, I write it as 4 over 4,000. So it's the same value. This is still like 1 over 1,000, they're equivalent, but this will make it easier for me to separate it into fourths now. Okay, so the halfway point is 2 over 4,000, and you don't need to reduce it. I'm not worried about anything like that. And then the quarter of the way mark would be 1 over 4,000, and then 3/4 would be 3 over 4,000. And then from there we can draw our midline. It's just that 0, y equals 0, so it'll just be the x-axis. And then we need to scale the y-axis also. So our amplitude is 20. We don't need to go like 1, 2, 3, 4 all the way up to 20. We can just put 1 mark up here for positive 20, and then 1 mark down here for negative 20. And then now we just need our points. So this is a sine function. So for sine, we start at the midline. So at 0 will be on the midline. We end at the midline, so 4 over 4,000 will be on the midline. And then halfway through will be on the midline as well. And then from there, there's no reflection or anything, so our quarter of the way mark, we're going to go up to a maximum. So at 1 over 2,000, or sorry, 1 over 4,000 will be up at 20 at the maximum, which is 20 above the midline. And then our 3/4 mark at 3 over 4,000 will be at negative 20 down here at the minimum. And then from there, we can just connect them. And then we're good. We have a model that gives us the pressure P as a function of time. So it's going up to 20, down to negative 20, and oscillating between the two the entire time. Okay, so example 3, 2 people swing jump ropes. The highest point in the middle of each rope is 80 inches above the ground, and and the lowest point is 2 inches. The rope makes 2 revolutions per second. Write a model for the height h in inches of the rope as a function of time t in seconds, given that the rope is at its lowest point when t is equal to 0. Okay, so starting with the maximum, that's just the highest point overall. So it tells us that the highest point that it reaches is 80 inches above the ground. So our max is 80 inches. And then minimum is the lowest point. So it says our lowest point is 2 inches above the ground. So our minimum 2 inches. And then the midline. So the midline has to be the halfway point between the max and the min. Not necessarily like the max and the ground, so it's not going to be 40, but it has to be halfway between the highest point and the lowest point would be the midline. So if we want to find the halfway point between 80 and 2, we can do 80 plus 2 divided by 2. We're just like finding the average of those two. So 80 plus 2, 82 over 2, and then that simplifies down to 41. So our midline would be y equals 41. Just that horizontal line that cuts the graph in half. And then for sine or cosine, we want to look at what the graph is starting at. So at the very end of the problem, it says, given that the rope is at its lowest point when t equals 0. And sine starts at the midline, and cosine starts at a maximum. So neither of those necessarily start at their lowest point. But if we take cosine and we reflect it, it won't start at a maximum, it'll start at a minimum. So sine always starts at the midline because if we reflect it, it's just going to reflect on the midline over and over again. So that one's no good, but we can use cosine with a reflection to get it to start at the minimum instead of a maximum. So cosine, and because at t equals 0, the height is minimum. So at t equals 0, the height is a minimum, so we'll use cosine with a reflection, and that means that we'll have a negative a value. So our amplitude won't be negative because that's a distance, but we'll have a negative out in front of our equation when we write it. Okay, and then amplitude. So remember, amplitude is, I'm going to go up here really quick and so we see like a visual. Amplitude is the distance from the midline up to the maximum or down to the minimum. So we don't have a graph right now for ours. We're actually not going to have a graph at all, but we can still find the distance from the midline to the maximum or the midline to the minimum. We could just do like 80 minus 41, or we could do 41 minus 2. Either one is totally fine. You'll get the same answer. So 80 minus 41 is 39. So the amplitude is 39. And then for the period, it tells us in the problem that the rope makes 2 revolutions per second. The period is how long 1 revolution takes. So if this is 2 revolutions per 1 second, and we want to figure out how long 1 revolution takes, we have to take that 2 revolutions and we have to cut it in half. So I'll cut this entire thing in half, and it'll become 1 revolution in half a second. So if 2 revolutions in 1 second, then half of that, half of both of them would be 1 revolution in 0.5 seconds. So the period would be 0.5. And then for writing the function, I'm going to write out the formula that has all the spots for each different kind of transformation. So in this case, it's in terms of h and t. So it'd be h equals a, and then we picked cosine, so cosine b of t minus h, and then plus k. So we have all that information pretty much. We have the amplitude, that's 39. We did say that we need a negative a value, so a is negative 39. We don't have b, but we have the period, so that can help us find b. So we have to do that before we can write our equation. So I'll do it off the side. I'm going to take the period 0.5. I'm going to actually just change it to 1/2. And I'm going to set that equal to the formula for period, which is 2 pi over b. And then now I can use that equation to solve for b because that's my only unknown. So I'm going to cross multiply. So 1 times b is b, and then equals 2 times 2 pi, so 4 pi. So we have b equals 4 pi, and that's the part that will actually go into our equation. So you can just kind of add it over to this line, b equals 4 pi. And then there's no phase shift. We just decided on cosine with a reflection. And then we found the midline as well. So that was 41. That'll be our k value. Remember, the k and the midline are the same because it represents a vertical shift. Okay, so we have everything. So h equals a, the amplitude is 39, but we're doing cosine with a reflection, so it'll be negative 39. And then cosine b, so 4 pi. And then t, no h, so we don't need the parentheses. And then plus k, so plus 41. So h equals negative 39 cosine 4 pi of t plus 41. Okay, and then example 4 and example 5 are really similar. So write a function for the following sinusoid. That just means like sine or cosine graph in this case, just a fancy word for it. So we're going to go through and find all these different pieces of information, and then we can use that information to write the function. So for the midline, the vertical shift, when I look at this graph for example 4, it's kind of hard for me to see the midline. So if it's ever hard for you to see the midline, remember that it's just the max plus the min divided by 2. It's just the average of the two values. So leave yourself a note for midline. You can do max plus min, and then divided by 2. Sorry if that's a little small. So our max, our highest point, we can see it on here, is 13, and then our lowest point is -5. So that's our minimum. So we can do 13 plus -5 or just -5, and then divided by 2. 13 minus 5 is 8, divided by 2. So we end up with a midline of 4. I'm going to add a y equals 4, and then I'm going to draw that on my graph as well, so it's a little bit easier to see it. So it looks like this is scaled by 2, so my y equals 4 is going to be right here. Okay, and then for the phase shift, so it really is up to you. I think before you have to decide the phase shift, you really want to pick if you're going to use sine or cosine. So I'm going to jump down to the very last thing where it asks for sine or cosine. So I can see my graph starts at its highest point right here. So at 0, it's at its highest point. So I'm going to use cosine, but you could write this technically with sine. I'll explain how in a second. So for sine or cosine, I'm going to put cosine. And then since I'm already starting at my highest point, I'm going to put no phase shift. And this is only no phase shift if you pick cosine. Technically, if you are looking and you're like, oh, I think it starts like right here, or it starts right here, or it starts right here, all of those are perfectly fine starting points, and those would make it so that you have to pick, or I guess even right here, those would make it so that you have to pick sine because they're starting at the midline. You would just have to incorporate a phase shift since it's no longer starting at 0. I would always try to start at 0 because it just means that you have like less transformations to put into your equation. Sometimes it's the case that you just can't though, like it's kind of in between instead of like exactly on a max or the midline. Okay, so the next thing is the amplitude, which the amplitude is the distance from the midline to the maximum. So or the midline to the minimum. Our midline is right here at 4, and it's going up to a maximum of 13, or we can look at it from right here. So if you're not sure, you could just always do like the max minus the midline. So in this case, 13 minus 4, which is 9. So our amplitude is 9. And then for the period, we have to look at how long it takes to repeat itself one time. So if I'm saying this is my starting point and you can pick a different starting point, that's fine. It goes down and then it comes back up right here. So this is from 0 to pi over 4. So the period would be pi over 4. And you don't have to only pick that section. I think that's the easiest one for this graph, but we'll see on the next example. There's maybe some different ways to look at it. So it doesn't have to always be that same section. We use this one. It just has to be one repeating portion. So technically I could find like this section, that's before it starts repeating itself. Or if I say it's sine, it starts right here, I would be finding that section, and they should all end up being 4 pi because it's just one repeating portion. It's repeating itself over and over again. Okay, so we have the period. Before we can write the equation, though, we need to find b. So I'm going to take that pi over 4, and I'm going to set it equal to the formula for period, so 2 pi over b, and then I have to cross multiply. So pi times b pi equals 4 times 2 pi, so 8 pi. And then if I divide both by pi, those pi's will go away, and we'll just have b equals 8. And that's the part that we need to plug into our equation. So you're never just plugging the period into the equation, you need b itself, but they're related. You get one from the other. Okay, so our formula for kind of taking all those different transformations and putting them in would be y equals a, and then cosine b of x minus h, and then plus k. We have all the information now. So we have b, we picked cosine, we have the amplitude, that's a, and then we have the midline up here, that's k. And then we decided to do cosine, so there's no phase shift. So altogether it'd be y equals a, so 9, and then cosine of b, so 8, and then x, no parentheses because we don't have an h value, and then plus the midline, so plus 4. So y equals 9 cosine 8x plus 4. Okay, and then example 5, last one. So write a function for the following sinusoid. Same thing, we're going to go through midline, phase shift, amplitude, period, sine, cosine, and so on. It would be a good, if you're watching this video on your own, to pause it and kind of test yourself to see how much you can get on your own, and then kind of play it just to check your work. So we're going to go through the midline, and then before we do that, we'll decide on, or before we do the rest, we'll decide on sine or cosine. So for the midline, it's just halfway between the maximum and the minimum. If you can't see it on the graph, you can just do that like max plus min divided by 2 that we did over here. So that's what I'm going to do. We can see our max is 1, and then our minimum is -3. So we'll do 1 plus -3 or 1 minus 3 and then divided by 2. So 1 minus 3 is -2. Divided by 2 is -1. So our midline is y equals -1. And then that midline is also going to be our k value. So just leave yourself a note maybe to make it easier at the end. And then before we decide on phase shift, we really want to pick sine or cosine. So if we look at where we're starting on the y-axis, so at 0, we're at what looks like, actually I'm going to backtrack and draw the midline in, but it looks like we are starting at the midline. So we'll add our midline in. It was y equals -1. So that blue line. And then now that we have it, we can see that at 0, we're starting at the midline. So we're going to use sine because sine always starts at the midline. Technically, you could use cosine. You would just have to do cosine with a phase shift because with the first maximum, it's happening right here. Okay, again, just I would always try to avoid using a phase shift if you don't have to. So always look at where the graph is at on 0. Most problems that you have will start like at 0 and a max, or at 0 and a minimum, or the midline exactly. So you can use sine or cosine without a phase shift. There may be a few problems that you see where you have to use a phase shift no matter what. Okay, so for sine, we said we're starting at a midline. So for phase shift, we don't need any, so it's exactly on a midline at 0. And then for amplitude, that's the distance between the midline and the maximum. So that is this distance right here. We're going from -1 up to +1, so the amplitude would be 2. And then the period is just one repeating portion. So it doesn't have to, you don't have to use the same portion as me. There's a bunch of different like ways that you can look at this one specifically. So if we're looking at where we're starting, we go up, we come down, and then right here is where it starts to repeat itself again. So if you can't tell what that exact point is, or you're not sure, you don't have to use that section technically. So you can kind of tell like that would end up being a 4/2, so the period should be 2. But if you can't tell, or if you ever have one where it's even more unclear than that, let's say I think it starts here, it goes down, it comes back up, and then it starts to repeat itself right here. So that distance is going from like 5/2 to down to 1/2. So we could subtract those. This is just a couple of different options that you can do to find the period. So 5/2 minus 1/2, 4/2, which is 2 also. So it simplifies the same way. On this one specifically, the only 2 exact points that you have, if you wanted to use those, this one it goes down and then it stops on this exact point, but we can see that's kind of like half of one period because it goes down but it doesn't come back up. So if I wanted to, I can find the distance between these two, 1/2 and 3/2, and then just double it to get the second half of the period. So the distance between 1/2 and 3/2 is 1, and then double it to get 2. So we end up with the same exact thing as we've gotten on every single different kind of way of getting it. And then before we can write our equation, we know the period, but we just have to find b. So we just have to take the period 2 and set it equal to the formula for period, so 2 pi over b. I can think of this as like 2/1, and then, or if you want to cross multiply, or you could just technically multiply both sides by b if you wanted to. And then I have 2b equals 2 pi. That gets rid of the b down here. That's why we multiply both sides by b. And then from there, I can divide both sides by 2 to get b by itself. So lots of different approaches, so not just like one clean cut way to do it. So divide both sides by 2, all the 2's cancel out, and then you're left with b equals pi. And then that's all the different information we need. So I'll rewrite the formula down here that has all the different spots of the variables. So y equals a, and then sine b of x minus h plus k. So we have k, that was the midline. We have the amplitude, that's a. We have b from our period, that's right here. And then there was no phase shift, so that's all we need. So it'll be y equals amplitude, so 2, and then times sine of b, so pi, and then x, we don't need the parentheses anymore because there's no phase shift because there's going to be no h that we plug in, and then plus k, so our k value is -1, so we'll just do -1 at the end. So y equals 2 sine pi of x minus 1.